Hi, everybody. Mr. Wyatt here. It's good to be back with you. And today we're going to be looking at section 7 in topic 4, solving inequalities. And you'll notice today I'm wearing a very nice blue tie. That's because I care about you guys. You guys matter. So I want to look my best for you. So here I am in my blue tie. All right. So, anyway, solving inequalities. Which numbers are solutions of the inequality m is greater than 3. M is greater than 3. Well, it sounds to me like any number that is larger than 3 would be a solution to this inequality. So I have a list of some numbers here that I can test. Okay? We have 2, we have 2.9, we have 3, we have 3.1, we have 4. Now I'm betting you can look at this pretty quickly and tell me which of these numbers would be solutions to this inequality. Which of these could I substitute in place of the m and make a true statement? So I'll start with 2. Is 2, substitute in there, is 2 greater than 3? No, it is not. So I know 2 doesn't qualify. How about 2.9? Is it greater than 3? No, that's still smaller than 3, isn't it? How about 3? Is 3 greater than 3? No, 3 is equal to 3. Now, if this were a greater than or equal to symbol, 3 would be included. How about 3.1? Drop that in here. Is it greater than 3? Ooh, yes, that one is. So I'm going to write down 3.1. And then finally, 4. Test that one out. Substitute in for m. Is 4 greater than 3? Yes, it is. So which numbers are solutions of the inequality m is greater than 3? Well, 3.1 and 4. I could even put little brackets around this to show this is my set of solutions from these 5 choices, which are solutions to this inequality. Okay? It's almost like 3 is the bouncer at the nightclub. And in order to get into that nightclub, you must be greater than 3. And so 2, sorry, they get bounced out of there. 2.9, no admittance, pal. 3, hey, nice try, but get out of here. 3.1, yeah, you can come in. 4, you too, yeah, you can come in. Because the ones that are greater than 3 are invited to the party. All right, let's look at another example. Find which of the following numbers are solutions of this inequality. We have x is less than or equal to 12. And I have 4 different possibilities here that I can test out. Any one of these that is less than 12 or equal to 12 would be a solution to this inequality. All right, so let's test some out here. 3, and again, we'll just take the values that are here and plop them in over here, okay? In place of the x, and test them out. That's supposed to be an arrow. That's a terrible arrow. What's wrong with me? I'm a horrible artist. Okay, anyway, let's test these out. Let's try the 3. Is 3 less than or equal to 12? Well, yeah, it is. So 3 is a possible solution. Let's try the 10.5. Whoop, substitute that for x. Is it less than 12? Yes, it is. So 10.5 is another possible solution here to this inequality. How about 12? Let's test out the 12. Is 12 less than 12? No, 12 is not less than 12. But we do have the equal to here also. Is 12 equal to 12? Yes. So 12 is invited to the party. We have one more to test, 12.5. Substitute it in. Is 12.5 less than 12? No, it's greater than 12, and it isn't equal to it. So I have these solutions right here. Now again, I'm going to put brackets around it to show this is my solution set. You don't have to put brackets around it. Honestly, when you get to the assignment, it's just going to be multiple choice anyway, right? But I like to put brackets around my solution set. 3, 10.5, and 12 are the values in this list of choices here that would fit in this category of being less than or equal to 12. You know, the honest truth is on both of these, there are an infinite number of solutions to both of these. Like if m is greater than 3, aren't there an infinite number of numbers that are greater than 3? I mean, you could go with 4, 5, 6, 7, 8, 9. I could keep going forever. Okay? So there are an infinite number of solutions. And you don't need to know this as sixth graders. And I totally spelled infinite wrong. This is supposed to be an I, not an A. So infinite, infinite. There's a symbol for this, though. Some of you might know. It's kind of like a sideways 8. That's the sign for infinity. And that just means there is no end to the number of possible solutions. And I was just listing counting numbers like 4, 5, 6, 7, 8. What about all the decimal or fractional values? 3.1, 3.28654. I mean, we could just keep listing an infinite number of possible solutions. So that's kind of a weird thought if you think about it. There are an infinite number of numbers that are larger than 3. And there are an infinite number of numbers that are smaller than 3. But if I'm only taking the ones that are larger than 3, aren't I taking half of infinity? Ooh, mind blown. You mean this is half of infinity, but it's infinity? And the other half of infinity, which is also infinity, would be the ones that are less than 3? Oh boy. All right, well I'm getting myself confused now, for goodness sakes. All right, so now I want to talk about how we graph solutions of inequalities. So I'm going to show you, we do this using a number line. For example, if I have n is greater than or equal to 3, 3 is going to be kind of my most important number here. 3. Um, I'm going to put a little circle there, okay? So there's my circle at 3. Okay, that's my key number here. N is anything that's greater than or equal to 3. If a number is greater than 3, it's going to be over to the right. Because as you move to the right on the number line, the numbers get greater or larger. So I'm putting an arrow like this to show all the numbers that are greater than 3, 4, 5, 6, 7, 8, 9, 10. I'm making an arrow to show it'll keep going forever. Anything larger than 3 is going to be a solution to this inequality. N is greater than 3. But I'm also noticing n is equal to 3. Any ideas what I could do to show that 3 also is invited to the party? What could I possibly do to show that 3 is also a solution? Well, it's pretty simple. Instead of leaving this circle here open, I'm going to fill it in and make it what's called a closed circle. Okay? And that closed circle means that it's also equal to 3. 3 is included in my solution set. It's 3 or anything larger than 3 or greater than 3. Now look at the next example. H is less than 7. Now my key point that I need to look at is the number 7. So I'll find 7 here on the number line, and I'm going to put a circle there. Now if H is less than 7, it's going to be all of the solutions that are to the left of the 7. Because as you move to the left, the numbers get smaller on a number line. Oh, this is so sloppy. Okay, so I have my arrow going to the left. Hey, you know less than starts with an L? The less than symbol almost looks like an L that's been bent over a little bit, right? Less than, left. They both start with L. Now, should I fill in my circle this time? Well, this is not equal to 7, it's just less than 7. If it were less than or equal to 7, then I would want to close the circle. But this one I need to leave open to show, hey, 7's not included in our solution set. Okay, so this right here is known as an open circle. And we use the open circle to show no, 7 is not included in our solution set. It's just everything less than 7 or to the left of the 7. Hey, I'm going to show you guys one more little trick that might help because sometimes students are wondering, well, which way should my arrow point? When you looked at the greater than symbol, doesn't it look like an arrow tip pointing to the right? And what do you know? My arrow in my graph is pointing to the right. Here in the less than symbol, it looks like an arrow tip pointing to the left. And look at my graph, the arrow is pointing to the left. Okay, so sometimes that can be helpful too. The arrow in your graph will point the same direction that your symbol appears to be pointing if you think of it as being like an arrow. Here, R is less than or equal to 2. So my first question is, should I make an open circle or should I make a closed circle at 2? Well, since it's equal to 2, then 2 is included in my solution set. And so I'm going to use a closed circle to show 2 is included. So I'll put a closed circle here, fill it right in. Okay? And it's also everything less than 2, and that looks like an arrow pointing to the left, doesn't it? So that's what I'll do is make an arrow pointing to the left here. And this is so sloppy. I'm embarrassed how sloppy I am making my graphs here. You could probably do a neater job than me. But again, your assignment will be multiple choice. So it's everything that's less than 2, and it's also equal to 2. So I have a closed circle here. All right. N is greater than 1. One more of these examples here. N is greater than 1. So 1 is my key number, and should I do an open circle or should I do a closed circle? Now remember, we leave it open if that number is not one of the solutions to the inequality. We close the circle if that number is a solution. And so when you see the little equal to underneath them, it'll be closed. I don't see an equal to on this one. So this one needs to be an open circle, and it's going to be at 1 on our number line. There's my open circle. And since it's everything greater than 1, all the numbers that are greater than 1 are to the right on the number line. And again, the symbol looks like an arrow tip pointing to the right. Okay? So hopefully you get the idea how to graph these on number lines. And I'm going to let you in on a little secret. There is no practical use for graphing inequalities. You're never going to have a job someday where your boss says, "Hey, I need you to graph all these inequalities on a number line, please." So it kind of begs the question, why do we do this? The reason we graph these inequalities is so we can see visually what it means. Okay? N is greater than or equal to 3. Oh, it's everything larger than 3, and it includes the 3. We can see it right on this number line. Sometimes when we have multiple inequalities that we're comparing and we're looking for solutions that are shared by both, putting them on a graph can be helpful too because we can see where they overlap, but we won't do that in the 6th grade. All right, write an inequality for the graph. So now we're doing just exactly the reverse of what we were just doing. Look at this one here. I have an open circle at 2 and an arrow going to the right. Okay, open circle at 2. So is 2 one of our solutions to this inequality? No, it is not. Okay, but everything greater than 2 would be a solution. Now, I am not told what to use for a variable here, so I get to choose my own variable, and I'm going to go with x because that's, well, my choice. It's kind of a boring choice. And it's everything greater than 2, isn't it? That's what is shown in this graph. X is greater than 2. Notice there is no equal to here because this is an open circle, so 2 is not invited to the party. Let's do another one. This time my key number is 4, and I have a closed circle. It's filled in, and the arrow is going to the left, which are the less thans. So let's go with n this time for our variable. N, this time it's less than or equal to 4. 4 is included because it's a closed circle, so I have the equal to here, and everything less than 4 is to the left. So there it is. That's what that means. Now, if you want to solve an inequality, you do this just like you do equations. Remember with equations, if you had y minus 5 equals 8, you would have to add 5 to each side to solve it. We do that with inequalities also. I'll add 5 here. But just like with the pan scales, we have to do the same thing on the other side too. So I'm adding 5 on both sides. So y, oops, it's erasing now, is less than 8 plus 5 is 13. Okay, so that's how you solve inequalities. All right, I'm out of time. I will see you tomorrow.